In this video, we'll take a look at how to make a fully procedural raindrop ripple-like effect in Unreal using HLSL coding within a custom node. If you're new to HLSL or just discovered these videos and find yourself having trouble following along, I would suggest you watch the other videos within this playlist which go over the basics of some HLSL coding in Unreal. The link to this playlist is in the description below. To begin, we're going to start off fairly simple. We'll create a brand new material and start off with creating a custom node. On this custom node, we're going to want to create some inputs. We're going to create an input for UVs so we can at least connect up some texture coordinates. Once we've done this, the next thing that we're going to do is break down the raindrop ripple effect to the most simplest form possible. So if we think about it, it's really just a bunch of circles or ripples that start small and then animate spanning outwards. And these ripples are randomly placed or scattered over the UV space when they're drawn. So the very first thing that we might want to start with is how to draw a circle. We've done this a couple times before, but we're going to start from the very basics just so we can build up our code so we're not trying to accomplish something that's too complicated without having something to start with. So we'll start off doing some of this code in Visual Studio Code just so it's a bit easier to see the syntax highlighting. So I'll start off with a float for called result, and that stores our red, green, blue, and alpha channels. So I'm just going to set that to 0, and we're just going to initialize that variable. The next thing I'm going to do is make a float 2, so that stores 2 values for the point center. That's going to be the center of where our point or circle gets drawn. And in this case, I'd probably want that for now just to be the center of my UV space. So 0.5 and 0.5. And then what we're going to do is create another float 2, which will be our UV offset, which is pretty much going to be our UV minus our center of our point or circle that we want to draw. And then we're going to define our radius. So we'll make a float called radius and start off with a very small value. And then finally, we'll kind of draw our circle by doing a float, make a new variable called point distance, and get the length of our UV offset. And then to use all this to actually produce our circle, we'll do an if statement to see if that point distance is within our radius that we've defined. And if it is, it will output the color white to our result. So I'll set this to 1 for everything. And then finally, we have to return that result to output it. So that kind of ends up being our starting code. And we've done this before. If I go over here and I paste this in here, assuming there's no errors, there we go. We have a circle and we can control its radius by changing our radius variable. So now all we need to do is find a way to turn this circle into a ring-like shape and kind of hollow out the center. To do that, we're going to jump back to our code and we're going to modify a couple things. We're going to add some additional variables. So some variables I'm going to add is going to be to add something to control the radius of that inner circle and the outer circle, and it fills in the gap between those two radiuses. So to do this, I'm going to create a new variable. So I'll make it a float, and I'll call it radius min. And that's the minimum radius, the inside of the ring-like shape. And then I'll make another float called radius max, and this is going to be the outside shape or size. So there we go, the minimum is 0.05, the outside is 0.1. So it should be kind of 0.5 thick in between those two sizes. And then one thing that we might want to do just for an additional control is have the ability to add some extra thickness if we wanted to. So I'm going to make one more float, which is just going to be called maybe ring thickness. And that's just going to be an additional thickness we can add. So maybe I can add like a very small amount of additional thickness. And that's something that we can just control. So it's not required, but might be useful. So there's my 3 new variables. Now we're going to have to change our if statement to include that radius min and radius max, so it only knows to fill in the areas in between those two radiuses with white, so we actually see the output. So point distance is less or equal to radius. that's kind of okay, but we're going to flip this around a little bit. Maybe what we'll do is point distance is less or equal to, and instead of actually less or equal to, we'll do greater or equal to radius minimum, the minimum size of that inner part of the ring, and then we'll minus the ring thickness, because that might add some extra thickness. So if the point distance is greater or equal to radius min minus ring thickness, and point distance is less or equal to radius max plus ring thickness, then fill in as kind of white if it follows those conditions and matches that. So if we take this and we put that back into our code here, let's see what we get. Okay, now we have a ring-like shape. We can control the inner radius size and then also the outer radius size. And we also have a control to add some extra thickness if we want on both sides. So now we have our ring-like shape. Now going back to our code, we might want to add a little bit of a taper or fall off to that ring. Right now it just feels very thick. It's almost like a donut shape. It'd be nice to have a little bit of control over the gradient or tapering of the opacity on parts of that ring, particularly the inside of it, just to make it feel like a little bit of a fall off and a bit smoother and softer. So we're going to make some changes to do that. And before I do that, I'm just going to reorganize some of this code because this isn't as readable to me as if I do something like that. I usually try to keep the code simple as much as I can at the beginning so it doesn't get hard to look at, even though it usually does. But the next thing that we're going to do is try to get a bit of a taper or fall off or gradient on the inner part of this ring. So when I zoom up really close, this inside section, it'd be nice if there could be a bit of a gradient from the outside section tapering off to the inside section. So to do that, I'm not gonna color this ring in with a 1 value or just a color white. Instead, I'm going to define a new variable. So I'm going to make a float called alpha. And this will be the opacity, or kind of what we draw, but we're going to do some adjustments to it. We're going to use a smooth step to add a bit of a gradient. So I'm going to make this float alpha, this new variable, equal something like smooth step, and then radius min, so the minimum radius, minus the ring thickness. And then for the second parameter, we're going to feed our smooth step. It'll be radius min plus ring thickness. So on that inner part of the radius, the minimum side, the ring that's on the innermost side, it's going to do a smooth step, and it's going to use our point distance here. And if we do something like that, it should produce a bit of a gradient. One thing I'm going to do is I'm also going to wrap this smooth step inside of a saturate, and that just guarantees or kind of clamps it to be within a range of 0 to 1, so we don't run into any issues with ranges or values being returned that are negative or that are going over 1 and starting to glow. I'm just going to restructure this code, make sure my brackets are good, open, open, close, close, okay. And then we'll take this, pop that back into Unreal, see what we get. No errors. Okay, now I don't see anything yet because one thing, I'm not actually using that variable yet. So instead of 1 down here, we're going to replace it with alpha. And actually, I don't need to replace all these with alpha. I could just do result, and instead of equaling float for alpha, 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 all the way through, what I'm just going to do is this result plus equals alpha, and that should be fine. And if we take that, paste it back in here, there we go. We got a little bit of a gradient on the inner side of our ring now. And you could do the same thing with the outer side of the ring if you wanted to. You know, it's the same kind of approach, but this is kind of what we want for now. So now we have this little bit of taper. So if we were to modify some of our values, like maybe what we can do is if we reduce the ring thickness. It's very, very subtle. If we increase the ring thickness, see it a little bit more. Ring maximum, ring minimum. You can start changing this and you always get that little taper. So now that we have this gradient, the next thing that we're going to want to do is probably make this ring a little bit thinner, but we're also going to want to have a random position and a random radius. Having all these rings be the same size, probably not ideal, and we want them to spawn at random locations. So that's the next thing that we're going to do. Now, before we go too much further, we should just clean up our code a little bit because there's some things in here that we no longer use. Now that we have a radius minimum and a radius maximum, this radius variable here is no longer really used. So we can remove that and just start to do a bit of cleanup on here just to make sure there's nothing that we have in here that we're not using. Now, the next thing that we're going to do is have to add a couple more variables. So first thing is we want to generate random position or just some random values. And we want to create a loop to place these different raindrop rings on different areas of our UV. So we need a variable for how many drops we're going to place. We also need a variable for the offset range. Within what range is it going to choose a random number to offset these pixels by? Or where is it going to draw these pixels on the UV space? And then we'll need like a seed value to generate some numbers that constantly change. And we've kind of done this in some of our previous videos as well. So it's a little bit of reuse of what we've done before, but adding a bit more complexity to it. And then maybe it'd be good to have a control to adjust that inner fade as well. Right now we have that smooth step fade for the inner part of the ring, but we have no control over it. So I'll block something in for that as well. So I'll make a float called maybe fade inner. Just set it to like some low value for now. It's not going to have any functionality yet. And then we're going to create our seed variable. So float2 seed, and we'll make that a float2 because it's going to hold two numbers, x and y or u and v, two values. So those two values are just going to be some random numbers. So 1, 2, 3, 4, 5, 6, and 7, 8, 9, 0, 1, 2. It could be whatever you want. It doesn't have to be these numbers. But just do something with a couple decimal places so you get some somewhat feeling of fake randomization in there. And it really jumbles up the numbers. And then we need one more variable for our offset, also float2, because x and y, or u and v, has to place that pixel on a random spot in both directions, left and right, and up and down. So we'll call this float2 offset range, make it a float2, and its range will be -1 to 1. And we're going to set up our UV space to be within the range of -1 to 1 instead of 0 to 1, just to make this a little bit easier to understand, but it doesn't really matter too much, but we'll start with that. And then finally, one more variable for how many droplets or how many of these little circles or rings we're going to draw. So I'll call it float drops, and I'll just make it 100 for a starting value. So now we have our variables defined. Now we need to make sure these variables get added in our code to actually affect something and to have functionality. So let's start off with creating our loop. So what we're going to do is start our for loop. So it could repeat what we've done here, but multiple times to place our circle or ring in different areas using that seed value for some fake randomization. So to do this, what we're going to do is we're going to have to restructure a little bit of our code because this will get a little bit more complex now. So I'm going to start off with our for loop. So I'm going to start it here. For int I, say integer, equals 0. I is less than the number of drops that we've defined, which is 100. Then I++, and then it runs everything within the brackets. And we're going to put all this stuff within those brackets. So, like that. And now we have to use that seed value to generate a random number that's unique to every time it runs through this for loop. So what we'll do is we'll make the seed equal fractional values of the seed times 1, 2, 3, 4, 5, 6. This is going to times it by some number and give it a random seed value every time. Or not random, but a new value for our seed every time it runs through one of these iterations of this for loop. So you don't get circles placed on the same spot twice. It'll kind of be a different number each time. Now what we're going to do is make a new variable, float2, called random offset. This will be our random offset produced from that seed variable. So we'll make it a lerp, which is a blend. We'll take offset range x, which we have here, offset range. When I say x, it's referring to this first number. Y will refer to the second number. So offset range.x, and then offset range.y, and then our seed value as alpha, or opacity. Now seed value, you might be wondering, how's this working? Well, since we used fractional here, even if this number, seed times 123.456, produces some really crazy value, like 5,000 or 2,000 or 157, how can that number be used as an alpha? Well, since it's wrapped in a fractional node, a fractional will only take the decimal points of it, so it ignores what the number actually is and always gives me a number between 0 and 1. So I never have to worry about that alpha going negative or that alpha going over values of 1. So that fractional value can be really useful if you need to take large random numbers and just extract something that's clamped within a range of 0 to 1. Now at some point, the radius of the circle or ring that we're drawing, we're going to want it to grow and expand outwards as time passes. But we're not going to worry about the animation component for now. We want to get our placement working and get everything else working before we even worry about that. So I'm going to block in a value here, another float called radius. Not radius min, not radius max, just radius. And I'm just going to give it a fixed value for now. Later on, we'll add a bit of animation to this value, so it's changing. But for now, I'm just blocking in a number so we can use it, and later on add the animation. The next thing I'm also going to do is produce another variable called offset, which will be our kind of final offset. And again, float2 for x and y, and offset will equal our UV space minus 0.5. So what that's going to do is make the center point of our UV 0 instead of 0.5 and 0.5. And then we'll minus whatever random offset has been created or whatever those numbers have been, and that gives us our final offset. And then instead of using point distance equals length UV offset, we're just going to change it to length offset. And then we have our alpha here. We got our smooth step, radius, min. We're going to change that now to just radius, this fixed value here. That will eventually be animated. And then what we're going to do is minus, not ring thickness, we're going to minus fade inner, that value that we added to control the fade on the inside of the ring. And then for the second parameter here, we're going to do a similar thing, radius plus fade inner. Oops, inner, there we go. And then point distance. And then if point distance is bigger or equal to not radius anymore, or radius min, just radius, and not radius max, just radius, and then ring thickness, okay. plus equals alpha, and then return the result. So what we're getting out of this is produce a different seed number, use that seed number to produce a random offset, use that random offset to give us our final offset, which we're going to use for drawing where the point or circles are. So when we run this code now in Unreal, assuming I have no mistakes here, we should get our circles or our rings being plotted all over our UV space, so it's not just in the center anymore. So let's paste this in, run it. Okay, no errors. There we go. We got circles or rings placed all over the place. They all have that little fade on the inner side. And does our fade inner control work? So 0.001 or 0.05, 0.03. Okay, so if it's within the range of our minimum and maximum, then we're going to see a nice fade. If it goes over our radius max, then it's just going to clip off. So if my radius min is 0.05, my radius max is 0.1. If our fade is something like 0.01, there we go. We see a nice little fade there. And we have something to control that. So you need to take into consideration your minimum and maximum. Otherwise, that fade might look a bit sharp. But now we at least have a control to adjust that. Now I'm just going to leave it at a default or whatever value I had it originally, 0.005. And it doesn't look too bad. We got nice little rings plotted all over the place. So next thing we want to do now, we got the random position working. We need animation and the radius to grow as time passes. So we need to introduce time. Now, sometimes in Unreal, time can be difficult to work with. I'm just going to show us as a quick example. If I create time and I preview it, it just shows this really bright color because it's just a number that's constantly changing. If you want to debug that number, we can connect our time to a debug float node. I'm just going to preview this so we can see what it's resulting. So that's the time. It just keeps going up. As long as Unreal is running, the numbers just keep going up. And it's hard to work with that because it could be 50,000, it could be 100,000, it could be 5,000. You could divide it by numbers, you could do all kinds of things. But again, that fractional node can be pretty useful because I can just run this time through I'll just stop this for a second, run it through a fractional, then put it in here, then preview it. Now it just extracts the decimals. And it's giving me numbers, but it's always going from 0 up to 1 and then back. So that can be useful if you just need to get some decimal point extracted from a bigger number. It's kind of always within that range of 0 to 1, so makes it a lot easier to deal with. So I'm going to use that to make sure our time values don't go crazy. Now, if we want to add time to our custom node, we need an input for that. So let's add that. Let's go to our custom node here. Let's scroll down here, add another input, call it time, and then connect up our time. We're not using it yet, but now we at least have the ability to access that time node or that variable that constantly goes up higher and higher. So now let's take a look at how we can start to modify our code and introduce that time to make each one of these circles or rings be plotted as a smaller ring and then grow or expand outwards as time passes and then have them fade off gradually. So we'll go back to our code. And we need some sort of control as well to control how long that duration or cycle lasts. That fades off or grows those rings or circles from a smaller size to a larger size. So I'm going to add one more variable up here. Float duration. Let's make it equal 1 for now. And then we're going to go back into our for loop. I'm just going to cruise over this code, make sure we have nothing that's a problem here, so we get our seed value randomized, or just produce a new seed value. And then we do our random offset. Okay, so after we do our random offset, we can use this random offset to also randomize our animation a little bit. So I'm going to create a new float called cycle and make that equal our duration, that value up here, it's 1. We'll take that and we'll plus it to a random offset. It's a rand offset. We don't know what random offset's producing, but just to make sure it's not like a crazy large value or something. This may not be required, but I'm going to do it for safety. I'm going to throw it into a fractional node so we get some decimal values between 0 and 1. And another thing you can also do if you need to clamp something between 0 and 1, but cheaper than a clamp, you could also use saturate. But in this case, I'm just going to use frac for this. That should be fine. And then I'm going to create another float called pulse. So our cycle gives us our duration and then a random offset. So it gives us this duration, plus it adds some additional decimal value just to give it some variation. So it's not always 1. It's going to be like 1.3, 1.2, 1.8. It's going to be a little bit different each time. And then our pulse will equal a fractional of time divided by our cycle. So this will give us some kind of totally random decimal value between 0 and 1. And then what we'll do is we'll modify our radius here. So we already have our radius. So right now it's fixed value of 0.05. What we're going to do is radius is going to equal radius min plus whatever this pulse value is, so it's making a little bit of a different size, multiplied by our radius max minus radius min. And that's going to give us a little bit of a different radius. And since it's controlled by that pulse value that has that time in there, it's going to change the size of the radius to kind of grow outwards and expand. And now that we have all of that, we have our offset here, point distance, our alpha, and then we have our checking to see if we're within the ring's minimum and maximum plus any sort of thickness we've added. And that gives us our result. And to make sure our result is within the range of 0 to 1, I'll use saturate and just throw it inside there. And then if we take all this, throw it back into Unreal, let's see what we're going to get now with that animated pulse value and cycle. Okay, so now we have our rings. They spawn smaller, then they grow outwards, and then they kind of pop off and disappear right now. They just, when we see them disappear, they just disappear. They don't fade away, which kind of makes the effect not as nice as we'd hoped. So how can we have these fade away? Well, we need to taper that alpha or opacity over time. So let's take a look at how we're going to be able to do that. So what we want to do now is when these circles reach a size limit or when they reach their maximum size, we want them to fade off, not just pop away and disappear and respawn. So we're going to multiply them by a value that will reduce their brightness as time passes and they get larger. So if we go back to our code, the way that we're going to implement this, and there's a ton of different ways you can do this. This code is not really the most optimal. We're kind of just going through it, producing something, and then after we can always go back, clean it up, make it into a function, optimize it. But the hardest thing is getting it working. So the easiest way I can think of controlling the fade of our rings without reworking everything or totally taking a new approach, or really just the most simplest way, is just to multiply it by value. If you multiply anything by 0, it becomes 0. So we can just take our alpha value down here and multiply it. We could do something like alpha multiplies equals, so it multiplies it by something and assigns it as a new value. And we can put something in there that will control its opacity. If it's alpha multiply equals 0, it'll instantly go to black and not be visible. If it's 1, it'll stay white. If it's 0.5, it will fade it off to gray. So we can control the overall strength of this by just multiplying it. So what we're going to do, I'll leave that empty for now. We're going to go up here. We're going to define yet again another variable. We're going to call this float fade outer. So we're going to add outer fade. And we'll just make this a really small number for now. And now that we have that variable, we're going to add one more variable in here called radius limit, which will be the limit of when it reaches a certain size. That's when it's going to fade off. It's going to help us control our fade that we're going to apply to that alpha, or that multiplication that we're going to apply to our alpha. So what we're going to do is under, we could put it really anywhere, but under its point distance here, I'll make another float, and I'm going to call it radius limit. It'll be a radius min. And then what we're going to do is add seed-wise, so it's just a little bit of randomization in there, or at least some random decimal number. Again, our seed is going to give us fractional seed times whatever it is, so it's just going to give us a little bit of a variation. And then we'll multiply that by radius max minus radius min. So that's our radius limit, and then we're going to use that here. We're going to multiply our resulting circle or ring by a smooth step, and we're going to do radius limit minus fade outer, so we can control that fade, and then radius limit again plus fade outer, and then point distance. And actually, this might give us some unwanted values, so we're going to put it in a saturate. So it clamps it between 0 and 1, and we're going to start with 1 and then minus our smooth step. Now, why do we do 1 minus our smooth step and then all this radius limit stuff? Is because if we just have a smooth step, it's actually going to fade in. It'll still pop off when it ends. By doing 1 minus, we invert the mask, or kind of the value that we're producing. So by inverting it, it'll help it fade out and not fade in. So if you want it to fade in instead of fading out, you could leave it as just smooth step and then whatever we're doing. If you want it to fade out, then we do 1 minus, that inverts everything, or inverts the value. So we end up with the opposite value. So it's actually fading out. Now that we have that, kind of have our full set of code here, we'll copy it, throw it back into Unreal, see if we have any issues. So right now, everything's just popping off. If we throw this in here and hit enter, okay, so there we go. Now when the circles fade off, see how they fade off from the inside and then go to the edge, and they get smaller, 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 and then fade off. So it's a nice little effect that makes it get thinner and then disappear. So when you watch it from far away, it feels much more gradual. So it's a nice little bit of a fade. And if we have that thicker or thinner, it'll also kind of adjust to work with that. And then we have our duration control here, which we haven't played around with, but if I put it to like half, you can control how quick they fade off, really fast or much slower. So there it is, our final result. Again, you can play around with this code, modify it, probably optimize it further and make it a bit easier to look at as well. But this is kind of a bit of a walkthrough on how we can start to make these kind of effects, adding a bit of animation, taking a simple shape, playing with some smoothing or gradients, and you can start to get these more complex effects that would be hard to do unless you use an animated texture. But now we can have it all done procedurally. So that's pretty cool. And if you're interested in more of this stuff, check out the rest of the videos that I have on HLSL coding with Unreal, and there might be a few tricks or things that you pick up there. And I'll definitely add some more videos. But if you've enjoyed this video, if you learned something new, make sure to subscribe, like this video, and if you're part of the Patreon, which there's a link to in the description below, you'll also get access to the PDF for this video, which goes over all the steps in this video in a PDF form in a little bit more detail, and you'll also get the source code or the code for this shader as well. So check that out if you're interested. Otherwise, let me know in the comments down below what you were able to create with this or similar code to this, and if you have any questions.